In this question, I want to talk about what happens when we do group operations and why it is that we want to avoid pandas group by apply, and also, critically, what we can do about it. And so in order to do that, I want to return to our trading data. Here you can see we have some trading data. And in that trading data, we might want to perform an operation, a very simple operation, like ask, what is the weighted average price? Take the volumes as the weights, and then see, what is the weighted average price? A large trade maybe gives us more information than a small trade. Each one of those signals may need to be weighted based off of the size of the trade that was performed. Well, it turns out that this is a little bit tricky. And the reason this is a little bit tricky comes down to how group by works and the optimizations that are available in group by. Let me show you what I mean. Here we have a much simpler piece of data. We have weights and we have values in a smaller structure. And in this structure, well, we could solve this problem pretty easily. We do a group by. We group by the entity. We then do a mean. That gives us the mean of the weights and the values for each entity. And then we do a product on the axis equals columns. No, this is going in exactly the wrong direction. This is not a weighted average at all. In fact, if you think about it, for the weighted average, what we need to do is we need to do an operation where we see all of the weights at one time, all of the values at one time. We can sum up those weights. We can see what contribution for each one of the entries that you have makes to that weight. So we still do want to group by the entity, but we actually need to do an operation in that UDF looking at, here I'll separate this a little nicer, looking at all of these weight column, all of these weight values together, sum those up, see what percentage of the total this is, and then multiply that times that value. Well, the reason this is problematic is, understand that the complexity around pandas.groupby is largely informed by how do we do these operations quickly. And the reason for that is, anytime you have a pandas group by operation, you can just loop over the groups in pure Python. That's exactly what's happening here when I'm printing them out using the positional argument unpacking syntax. I'm basically saying, if you want, you can take what the group key is and the group itself in any group by operation, here grouped by the entity, and just loop in pure Python. And because you can do this, well, a question arises, why not? And the reason why not is you want your operation to be maybe a little bit more fluently expressed using the pandas API. You may want to use a built-in operation in the case of a mean or a sum or a cumulative sum. Or you might want to have some user-defined function, and you might want to find some additional speed there. Well, where are you going to find that additional speed? Because here, if I'm doing an operation on this group, like I'm taking the sum of the weights, and then I'm taking each one of the individual weights and their sum, like this, where am I going to get some improved performance? If I have to define this as a user-defined function, I'm not really going to get any performance out of this if I can't really formulate this that easily in terms of built-ins. Maybe I can. Maybe no, because I have to still operate on the groups, so I can't quite do that. Kind of limited in terms of where I can find performance, until we consider that we don't want to perform this operation on just one group. We want to perform it across all the groups and create from that a resulting data frame or resulting structure. And so the group by operation is really you put in a series or a data frame and you get a series or a data frame back out. Well, that subsequent series or that data frame, consider how do we create that? We have to allocate memory in order to create that. And when you look at the different group by modes, a lot of this comes down to the decisions behind the allocation of memory. In other words, when we do a group by ag, when we do a group by apply, when we do a group by transform, or when we do a group by with some built-in method, well, we're either giving pandas some hint for how it can allocate memory in order to make at least one part of this, not the application of the underlying UDF, but the stitching of this back into one structure, well, we can make that a little bit more efficient. Consider this. Groupby.ag is all about aggregations. Well, sure, it's in the name. Well, what does that mean? That means for each group, you create one scalar value. What does that mean? That means that the result structure will be indexed on the grouping keys. In other words, there will be one value for each one of these grouping keys. What this means is if your data frame or if your structure has n rows wherein there are g groups, your result structure will have g rows. There'll be one row per group. Hold on a second. What this means is if I do a groupby.ag, I'm telling pandas ahead of time exactly how much memory it needs to allocate. And instead of having to allocate this in a bunch of small little chunks, one for each of the grouped operations, pandas can allocate all that memory up front and then just fill it in. If I'm doing a groupby transform, then I'm doing a transformation. Of course, it's in the name. What that means is for each group, I'm producing multiple values. Now, I may produce one scalar value, which then gets broadcast up to multiple values, but the end result is multiple values. What does that mean? That means the result structure will be indexed on the original indexing. There will be no change to the indexing. In other words, if your structure has n rows, your result structure has n rows. Transform means you're taking the original data and you're just saying, group them, but give me one result for each one of those groups and then broadcast that to the entire group. Or group them and perform some computation, and that computation will be the exact size of the group, and so just assign those to those. That's why things like group by cumulative sum is the exact same thing as a group by transform sum. Group by sum is the same thing as a group by ag sum. One of them produces one element, the other one produces one element per original source element. Well, again, you're telling pandas exactly how much memory to allocate. In the case of group by transform, pandas knows ahead of time, allocate exactly the amount of space that the original structure had. And so pandas can allocate all of that memory ahead of time, and it doesn't have to do expensive allocations. When you do a group by apply, what you're doing is an application. Well, hold on a second. That's in the name, but that doesn't mean anything. It turns out when you're doing a group by apply, you're doing an arbitrary operation. What that means is for each group, you produce anything you want. Any structure of any size, a scalar value, multiple values, whatever you want, group by apply lets you do it. That means that the result structure will be indexed on the grouping keys. Otherwise, you wouldn't know which computation corresponded to which of the groups, plus, or concatenated with, whatever you return. This is why when you do a group by apply, sometimes you get that original indexing duplicated, because that extra layer is group by apply saying, you're still going to want to go back and figure out which computation was which. I'm going to tack on an extra level of that index to indicate that for you. What this means is, if your structure has n rows, your result structure has m rows, well, there's no relationship between n and m. There is no known or predefined relationship. What that means is, for group by apply, you do not know how much memory to allocate, and so pandas has to allocate each one of the intermittent results, each one of the incremental grouped results separately, and then concatenate them, which means, and we can't guarantee because we don't know that much about internally how pandas memory allocation will work, and that changes over time as well, but in general, what you can anticipate is group by apply will be meaningfully and materially slower and more expensive in terms of how much peak memory it uses than group by ag or transform. In group by ag or transform, you don't have to do any memory allocation. Just in the restricted computation domain, it can just say fill in, fill in, fill in, fill in, fill in on a pre-allocated block. In group by apply, it has to compute, compute, compute. These can be scattered in memory. It has to bring them together and concatenate them into one structure, and it has to do that in an index-aligned fashion as well. And as it's concatenating the results, it has to keep the old results around while it's creating the end result. And so at some point in time, you're likely to have twice as much memory in allocation than what the end result looks like, because you need to be able to create each of the incremental ones and then create the duplicate. So you can't just resize that in place, because you can't resize a NumPy and DArray or a pandas.DataFrame or a pandas.Series or any of these pandas structures. What that means is we strongly want to avoid group by apply where possible. However, there is one other consideration that distinguishes these. Group by ag operates on each column separately. Group by transform operates on each column separately with a fast path that is triggered in such a fashion as to prevent you from being able to pretend that it can operate on the group as a whole. So this also operates effectively, at least semantically, on each column separately. Group by apply operates on the entire group. Only group by apply lets you see all of the grouping lets you see all of the values at once, which means if I had my series or my data frame here, and I wanted to do a weighted average, well, I need to know both the weight column information and the value column information in order to do this. And so it is relatively trivial for me to implement this by doing a group by on this and then an apply on this. This gives me each group as a whole. Here, let's spell lambda correctly. And I can say, take the weights for this structure, divide that by the sum of those weights so you can see what your contribution to the overall weighting was, and then take that result and multiply it times the value, and then compute the mean. And this underlying operation is relatively straightforward. I think this should be g value like that. There we go. And you can see we can encode it here pretty easily. The problem is, if the structure is very, very large and there are enough groups, here you can think we're doing probably 3 allocations for enough space for each one of these scalars and we're concatenating them, so maybe not so bad. But if there were some very large groups, then, or a very large number of groups rather, then this is going to be slow because we're going to do a lot of memory allocations on top of also having to call that UDF so many times. And so it's the case that where possible, we may want to figure out, is there a way that we can encode this using .ag or .transform? Well, in fact, there are some ways we can do this. Here's one way you shouldn't do that, surprisingly enough, works. If you set index, it turns out that when group by ag and transform operate on the groups, they operate on the groups and they're also given information of the original indexing. In other words, if I do a group by entity here, and I look at what the underlying groups that are going to be operated on, you can see I get an index structure here. So if I set an index, I can smuggle a little bit of data in to each one of the grouped operations. So I could group by entity like this, and then I could do an ag. Oh, this is absolutely terrible. But I could take the group. I could say, give me the level values for the weight, like that. I could divide that by the sum. Let's do this here, like that. Multiply it times the group, and then compute the mean. And I believe that'll work. Let's do this. And the last thing we got to do is we have to, this is going to give us here we have to do get level values. So we'll have to do a sum like this on those. And here we'll have to, and then we'll do a sum there. And there you go. Not a good idea. Smuggling data through the index, not a good idea. But there is another way we can solve a problem like this. What we would do is we would try to see if we can decompose the multi-column operation into a single column operation. And it just means really breaking this down. The downside of this approach is the resulting code is going to be much harder to read, and it's not going to look a whole lot like this because we have to break down these operations so that each one of the steps can be smuggled in the restricted computation domain. So what we would likely do is we would likely first group by the entity, and that gives us each one of those entities, and look at the weight column all by itself. When we look at the weight column all by itself, we can compute what the sum weight is for that particular group. And so that's one of the factors that we need. We could do this as a transform with the sum. So we get that broadcasted out. So each one of the groups now has that additional information, and we could add that as an extra column. So here, this is the total weight. There we go. So now we have the weight and we have the total weight here. When we have the total weight, we can see what the percent weight is pretty easily. This would just be in here. Let's do this as a lambda df, just so we get this right. Lambda df. And here, this would just be our weight column divided by our total weight column. So again, we are stacking another column on, and there that's the percent weight. You can see how those line up. Then what we need to do is we need to take the weighted average mechanism, and we need to figure out how to encode that in one column. Well, what we could see is the weighted value is the multiplication step here. So again, we'll create another column, and we'll take the percent weight, and we'll multiply that times the value column. And now we've done the first part, which is we've pre-weighted the values. Now that we've pre-weighted the values, we should be able to group by each one of these and compute the mean on those pre-weighted values. It should give us what we want. And there we go. What you can see here is smuggling this in the index, not a good idea. Decomposing this into individual column level operations, you will likely see for a large number of groups that will be faster and materially faster. It's just kind of clumsy. The general guidance I would give is this is maybe worth doing if you later care about these columns as well, because you can argue to yourself that the step-by-step decomposition might give you a good result back. It might give you, here let's do a df dot, or let me do the following. Let me do this just on the weighted values here. But if we wanted these intermediate steps, what we might do is I'll pipe this. I'll get the data frame. Let's get that. So this should be identical to what we had before. And I'll join this up with this result. And do I not have index names here? That's the entity. That's good. What does this look like with just the underlying data frame? Okay, so I just have to name this thing. So here, this is the weighted mean. And here, I just have to join this here like that. And if it was the case that I wanted each one of these intermediate steps, then I think that this might actually be valuable for me to do. This is the group weighted mean. And if I wanted to step back and use these for other things, the contortion might be appropriate. So let me show you this assigned or applied to our actual problem. Here's our actual problem with the portfolio and the asset. Again, our goal here would be to figure out how we can decompose this. And the decomposition is going to look very similar to what we did before. We're going to take the trades. We're going to group by the portfolio and the asset, since we know we cannot cross that portfolio asset boundary. And we're just going to add on some columns here. So the first thing we're going to do is we're going to take the volume, and we're going to pre-compose this with the price. So let's actually first do that step. We'll take the trades, and we'll do an assign. And we don't have to do this in a grouped fashion just yet, because this is just going to operate on each one of these individually. So this is the weighted price. So this would just be the volume. There we go. The volume times the price. Now we have to divide these by, we need to see what that percentage volume is of the total volume. And so here, let's compute what the total volume was for each one of these positions. This will have to be grouped because we can't cross that position. We can't cross the asset. So here, we'll group by the asset. And we'll grab the volume column by itself. And we'll get the sum here. And we'll get basically what the total volume is there. Now, when we do that, we've got to just make sure that we index a line properly. So let's just quickly make sure that works. Let's group by the asset, grab the volume, and get the sum. See what that looks like. That's indexed like that. And then this thing needs to match up to my original trades. So if I do this here, that's named, and that is named as well. Let's just make sure that this should index a line for me. Should be smart enough to index a line on that level. Otherwise, I'm going to have to force it to index a line on that level. Well, that's a shame that it doesn't. So what I'll do here is I'll force it to index a line on that level by re-indexing this thing on this index and say level equals asset and see if that, yeah, there we go. So you can see we have the total volume. Now that I have the total volume, I can basically take this divided by the total volume. And sorry, this is the total volume. And multiply times the price. So I can construct each one of these steps individually. And then I can take my weighted price, or I can do my last group by, and this will be grouped on the asset with the weighted price. And I can do my mean of these. And now I should be able to get the weighted price from these. This is the approach that I might have to take. Here, there is the other way I could do this is I could do this with a transform sum. And if you think about it, each one of these built-in operations, there's always if it's an aggregation, there's a way to turn it into a broadcasting operation. I do this as a transform sum like this as well, and that should work as well. And here you can see, there we go, and we have our volume as a percentage of the total volume times the price. And by the way, this shouldn't be a mean here. This should be the sum since we already did that. So there you go. So you can see here, it's really just about decomposing these operations. Is it worth it? Well, if we needed these, it might be. And in this case, I actually think it is, because you might actually want to know what percentage of the total volume did any trader hold at any one point in time, what percentage of the total volume was a position. These might be things that you might want to have. And so in this case, we'll get the speed benefit and we'll get some additional columns on the side.